Hello students. So let's continue with the exercise problems. So we were doing problems based on similarity of triangles. So let's continue with the 12th question. So here they have given us two triangles ABC and PQR. It is given in the figure 6.41. So sides AB, BC and median AD of triangle ABC are respectively proportional. So let me annotate it. The sides AB, BC and median AD of a triangle ABC are respectively proportional to sides PQ, QR and median PM of triangle PQR. We have to prove that triangle ABC is similar to triangle PQR. Okay. So we have taken the triangle as given. So triangle ABC is, triangle ABC is similar to PQR. That's what we have to prove. So let's write it. We have to prove that triangle ABC is similar to triangle PQR. This is what we have to prove. So what they have given us is, they have given sides AB, AC and AD. AB, AC and AD and PQ, PR and PM of triangle ABC and PQR are in proportion. That is, AB by PQ will be equal to BC by QR will be equal to AD by PM. This is given. That is, side AB, BC and AD are proportion, in the sense if you take the ratios with PQ, QR and PM, it is equal. Okay. And AD is a median. What do we mean by median? It is a line from the opposite vertex. Suppose for the side BC, if you want to draw median from the opposite vertex, that is A, from there we have to draw a line which joins the midpoint of BC. So D is midpoint. Okay. Meaning BD will be equal to DC. Same thing with PM. PM is also median. If PM is a median, M will act as midpoint. We have to remember that. Okay. So let's continue. So from the given data, we have to prove that the triangle ABC is similar to triangle PQR. Let me take the given thing itself. AB by PQ, BC by QR, which is equal to AD by PM. Let's take the given thing. Now in the next step, AB by PQ, I can write BC as 2BD, isn't it? Because D is midpoint. So BC can be written as 2 times. For example, if BC is 10 centimeter, BD will become 5, DC will become 5, isn't it? In a similar manner, if you want to find BD, it is simply the half of BC. Or in other words, if we want to find BC, it is double of BD. That's what we have written. QR will be in this similar fashion. QR will be 2 times QM. That will be equal to AD by PM. And if you observe, 2 and 2 gets cancelled. So we are left with AB by PQ. That is equal to BD by QM. That is equal to AD by PM. Now observe the numerators AB, BD, AD. These are nothing but the 3 sides of the triangle ABD. I'll shade it, isn't it? These are the 3 sides of the triangle ABD. Similarly, observe the denominator PQ, QM and PM. These are the 3 sides of the triangle PQM. Now, what we have done is, we have proved that 3 sides of the triangle ABD and 3 sides of the triangle PQM are in proportion. Therefore, from the above result, we can say that triangle ABD is similar to triangle PQM using SSS criteria. But what we have to prove is, we have to prove that the bigger triangle is similar to the other bigger triangle. So here, if you observe, let me do it this side. So let me continue here. So if 2 triangles are similar, it implies the angles are equal, isn't it? So I can say the middle alphabet B is equal to Q. Because of two triangles are similar, corresponding angles are equal. Let me use this now. Angle B is equal to Q. Let me take it as equation 1. And from the given data, AB by BQ is equal to BC by QR. Let me take it as equation 2. This is given, right? From the given data I've taken. From 1 and 2, we can tell that triangle ABC is similar to triangle PQR. Let me show it again. So here, if you observe, angle B, let me take a different color. Angle B is equal to angle Q. We have proved it. And the sides containing the angle in triangle ABC is AB and BC. In triangle PQR is PQ and QR. If you observe, those four sides are in proportion. Therefore, one angle are equal and sides containing the angle are in proportion. Therefore, these two triangles are similar using SAS criteria. Okay, students, let's get into the next problem. Okay, students, let's continue with the next question. Let's take question number 15. A vertical pole of length 6 meter casts a shadow of 4 meter long on the ground, and at the same time a tower casts a shadow 28 meter long. Find the height of the tower. So here we have got a pole which is of length 6 meter. Let's take, so let's take a pole. Let's take a pole. So let's say this is the pole of length 6 meter. So the length of the pole is 6 meter. And let's take a tower. Say this is the tower. Okay. Here we have to find the height of the tower. We don't know what is the height of the tower. Let me take it as H. So let me mark the height of the tower as AB. And let me take the height of the pole as CD. Now, let's say the length of the shadow of the tower is so much from B to, let's say, E. And DE is the length of the shadow of the pole. Okay. The length of the shadow of the pole is given as 4 meter, meaning from D to E is the length of the shadow of the pole. Okay. And the length of the shadow of the tower is 28 meter. That is from B to E. So 28 meter is from B to E, from here to here. Okay. And obviously the angle will be 90 degrees. Let me combine the tops. As you can see, we have got a triangle. The figure is not good, or let me redraw it using a line. So it will be something like this. Okay. Let me again redraw it. Something like this. Okay. Bear with the figure. It's not proper. So here we have got two triangles. One is CDE, another one is ABE. So we have to find the height of the tower. So again, we are going to deal with similarity itself. So let's prove the triangle ABE and CDE are similar. In triangle ABE and triangle CDE. If you observe properly, angle E is common for both the triangles. So common. And angle B and angle D both are equal because 90 degree. Therefore, since two angles are equal, triangle ABE is similar to triangle CDE using AA criteria. Since two triangles are similar, corresponding sides are in proportion. Therefore, AB by CD will be equal to BE by DE will be equal to AE by CE. In this, we don't need this AE by CE. Let's take only the first two things. AB by CD is equal to BE by DE. So AB value is H, the height of the tower, and CD value is 6 meter, and BE value is 28, and DE value is 4. We need H, we don't need the 6, so let's transpose the other side. If we transpose the other side, H will become equal to 28 by 4 into 6. So 4 ones are 4, 7s are. Therefore, H value will become 7 into 6, which implies height is 42 meters. Therefore, the height of the tower is 42 meters. So here, what we have used is, we have used the similarity of triangles. We proved the two triangles are similar. That is this triangle. I'll shade it CDE, this triangle, and the entire triangle ABE. We proved it using AA criteria. Once they are similar, we have used the property. Okay. Let's get on the last question of this exercise. So the last question, if AD and PM are medians of triangle ABC and PQR, such that triangle ABC is similar to triangle PQR, we have to prove that AB by PQ is equal to AD by PM. Okay. So let's prove it. So what they have given us is, they have given two triangle ABC and PQR, the same one as the 12th one. So let's take triangle ABC, and let's take another triangle PQR. Let's take two triangles like this. One is triangle A, B, C. Another one is P, Q, and R. And we have got a median. So let's draw the median also. PM is the median, and AD is the median. So here it is D, and here it is M. So if AD is the median, then D will act as midpoint, and M will act as midpoint here. So what is given is, they have given that triangle ABC is similar to triangle PQR. So we know that if two triangles are similar, then corresponding angles are equal. Therefore, angle A will be equal to angle P, angle B will be equal to angle Q, angle C will be equal to angle R. Along with that, we can also say that the corresponding sides are in proportion. That is, AB by PQ will be equal to BC by QR. That will be equal to AC by PR. Okay. So what we have to prove is, we have to prove that AB by PQ is equal to AD by PM. So as I told you in many questions, if you want to prove such a ratios are equal, we have to take two triangles. Observe the numerator. In the numerator, we have got AB and AD. So which is the triangle that has got AB and AD? That is a triangle ABD. Let me shade with a different one. So it is ABD, this triangle. Okay. And PQM is this triangle, because it has got PQ and PM in it. So if we prove the triangles are similar, the shaded triangles, if we prove the shaded triangles are similar, then we'll get the required thing. How will we do that? So if you observe one angle in triangle, first let's prove it like this. Let's take the given thing, that is AB by PQ is equal to BC by QR, isn't it? that is equal to AC by PR, but let's take only this part. So here AB by PQ can be written as, AB by PQ is equal to BC can be written as 2 times BD divided by 2 times QM, because D is midpoint, M is midpoint. 2 gets cancelled. Therefore, we have got AB by PQ is equal to BD by QM. Let's take this as equation 1. And again, from the given thing, let's take angle B is equal to angle Q. Let's take this equation 2. From 1 and 2, what can we conclude? If you observe, one angle, that is B and Q, is equal. One angle is equal, and sides containing the angle AB, BD, PQ, QM. Observe, AB, BD in the numerator, PQ, QM. The sides containing the angle are in ratio, proportion, and the angle is equal. One angle is equal and sides containing the angle are in proportion. Therefore, the two triangles. Therefore, ABD is similar to triangle PQM. If two triangles are similar, we can say that the corresponding sides are in proportion. Therefore, we get AB by PQ is equal to BD by QM, which is equal to AD by PM. In that, we need the first part and the last part. Therefore, we can eliminate the middle one. Sorry about that. We can eliminate the middle one. Therefore, AB by PQ is equal to, we don't need this middle part. So let's take out this. Anyhow, all the three are equal, isn't it? So AD by PM. Hence, proof. So these are the problems based on similarity of triangles. So let's recapitulate what we have done so far. Okay, it will be a good revision. So, okay. So you can see there were three types of problems. One was problems based on AA criteria. Suppose the question is like this: triangle, prove that triangle ABC is similar to triangle PQR. If a question is like this, now remember the first part, that is A, the angle A will be equal to angle P. I'm sorry. Triangle PQR. So A will be equal to P, B will be equal to Q, and C will be equal to R. That is, angle A will be equal to angle P, angle B will be equal to angle Q, and angle C will be equal to angle R. This is very well known, but we have to just try to find the reason why these are equal. Angle A is equal to angle P, why? Angle B is equal to angle Q, why? Angle C is equal to angle Q, why? Suppose if you get reasons for any two, then it is done. Suppose you know reason for only one and you don't know the reason for other two, then remember, then you have to solve this by SAS criteria. And if you don't know the reason for any three of this, then you have to solve it by SSS criteria. And one more hint is, there are many problems in this exercise where we have to prove the ratios. For example, like this, AB by PQ is equal to BC by QR. For example, I'm just taking. So we have given with such questions. If we have to prove like this, remember we have to take two triangles. How do we get two triangles? Observe the numerator, AB, BC. Find the triangle that has got both AB and BC, take the triangle. Again, observe the denominator, it has got PQ and QR. Find the triangle that has got both PQ and QR in it, take the triangle. Now you got two triangles, prove that they are similar. If you prove that they are similar, we will get the required result. This is one sort of problem. There is another type of problem where it can be given like this: CA square is equal to CB into CD. If you observe, the CA square can be written as CA into CA. The CB dot CD is nothing but CB into CD. Now you transpose one CA to the other side, CB to the left hand side, CA to the right hand side. So it will become CA by CB, CD by CA, which is nothing but the previous type of problem, like this, isn't it? Like this type of problem. Same thing, you will get two triangles, try to prove that the triangles are similar. If you prove the triangles are similar, we will get the required result. These are the different types of problems that we have done so far. I hope you have understood. Thank you, students.